Hello guys, so in today's video we're coming back to our IMO playlist. So let's just dive right in. Today's topic is coloring proofs, which is a trick to solve a lot of questions in IMO. So let's just dive right in. So this is the lecture overview, so we're gonna look at what's a coloring proof and then types, 5 types, invariant techniques, but not completely invariant. IMO trick patterns, classic examples, designing a coloring. So starting assign colors or labels to objects so that constraints become visible. A contradiction or invariant appears. Okay, let me explain this clearly to you. So let's say you have a graph, a random graph. We don't know if, for example, a modular arithmetic graph. We don't know if it's mod 2 or mod 3 or mod 4 or what. Okay, so if we give a blue color to mod 2 and red color to mod 3, then we completely organize things. That is called coloring proofs. You organize data so that you can solve questions with these. So there are 5 types of coloring: checkerboard or chessboard, graph coloring, just like yes, now this is the modular coloring, just like I taught you before. State coloring, that is prime parity, direction. Game coloring, I mean improve the question by organizing the data. So most powerful for IMO, modular coloring. This is the most powerful mod, right? So first of all, the checkerboard coloring or chessboard coloring. Okay, first of all, we just have to know the scheme of the chessboard. Like opposite color will be too white or either too black. Okay, so if you remove two black or two white, there's a color imbalance because when you take a two into one square, that's one black plus one white. So we can't quite match up the imbalance. So that's called visualizing. Coloring is nothing but visualizing. Okay, color. Okay, mod 2. Okay, so as I said, mod 2, if even it's red, if odd is blue, that is in mod 3, if 0 it's red, just like it's even means the mod 2 will be 0, and blue like odd, mod 2 will be 1, and 2 means green. Just distinct colors for those. So this one is just a formula for conceptual exams. This is just logic, Color M equals N mod K. So color parity invariance. This is just like a checkerboard I taught you before. Black minus white equals constant. That's just even always. And color sum invariant. Yes, this is like this one, assigning distinct colors to different mods. Forbidden transition. Okay, now this is the plus or minus case. So for this, we don't require coloring in 99% of the questions, but there might be rare cases, right? So make sure of one thing. When it's even, red, odd is blue, right? So Matu 0 means red, 1 means blue. Okay? Remember that one like that, okay? So 0 means red, 1 is blue again, 2 is green, and here 2, red, blue, and green. And for 3, you can choose any other colors. So 5 standard IMO tricks, okay? Impossible reachability. Okay, this is the plus minus one, and the party trap, that is the checkerboard, you can say, and also the inversion types, and we can also say the modular arithmetic. And if you don't understand this, you should definitely see the lectures I've uploaded before on invariance, modular arithmetic, and the 10 problems I've solved. So those are the basement, so that if you look at those videos, you can understand this video. Okay? Pigeonhole via coloring. Okay, pigeonhole, I'll be covering this one later on. So today, let's just ignore this one. Cycle obstruction. Okay. So there's for example, let's say you take some turns for that one. Like you have a number and you keep on changing it, and finally you get the same number again. So that's a cycle, right? So these are just examples, okay? So tomorrow I'll be solving 10 tough IMO level, IMO level, IMO level problems on coloring proofs. So tomorrow, if you see that video, you'll be completely able to apply this knowledge, even though if you can't now. Okay, so tomorrow look at the video and be thorough in applying. Okay, first of all, identify movements or constraint and what flips or cycles, assigning colors to that quantity, test invariance. That's it. This is just kind of simple. You just color it and look at the data, you organize it, and then you just copy down the data and you're getting the answer ultimately. So common mistakes to avoid: choosing colors randomly without any structural justification. Like for example, for mod 2, we take even means that's red, right? And again in mod 3, if mod 3 is equal to 0, you take yellow. And that's completely bad because that's the mod value will be 0, but the coloring will be different, which means it's wrong, right? Overcomplicating with too many files. Okay, just coloring with different colors and making it organized is good. If you're coloring everything with different colors, it's really overcomplicated. You should color only what is needed. Okay. So not verifying invariance under all allowed moves. Okay, so this is just a basic thing. We always should look at invariance in all chapters of IMO almost. Forgetting boundary or edge conditions. Okay, yes. You're breaking the rules of the question, so that's right. So this is just a mental model like um, state A, start coloring, and state B, you choose a different color, and then state X, I mean, first of all, you come to state C and do a different color, and after that, finally come to state X. That is the target, that is copying down the colors. So the one-line summary: coloring proofs work by encoding a complex system into discrete states, so that invariants or impossibilities become visible through simple coloring transitions. This is exactly what I taught you in the whole video, right? So remember about this thing a lot. So that's it for today, guys. Tomorrow I'm gonna be uploading a video on 10 problems on coloring proofs. So for today, that's it. So like and subscribe to my channel. Stay tuned for my AI building link. And bye. See you tomorrow.